Let's talk about inverter. The basic topology says that the inverter is just like this. In this system, there is two cases. Case 1, S1 and S2 are on, and case 2 is S3 and S4 are on. We have to consider these two cases, and these two cases does not collapse. These two cases to be arranged in sequential manner. That means case 1 will be occurred first and case 2 will be second. Then case 1 will be again established. Let us discuss case 1. In the case 1, positive supply of the battery is connected to here and negative supply is connected to here. Now the current will flow from the battery through the S1 switch and through the load, then S2, then it will return to the negative terminal of the battery, and in this manner the load will face a positive voltage of the supply voltage. Now talk about case 2, and the case 2 says S3 and S4 will be turned on and S1, S2 will be closed. In this case, the current will directly flow from the battery to the S4, and through the S4 this will flow through the load and through the S3 it will be grounded, and in this case the load will face a negative peak voltage according to the supply, and by arranging these switches just like this we can achieve a alternating voltage. That means here we will get positive voltage and here we will get negative voltage, same the value of the supply. But the funny thing about this cannot work. It does not work. Why? The first thing is, here we will, in the case of switch, we will use MOSFET, and the MOSFET has several characteristics just like. And second thing will, as we are using the MOSFET, we need to add a commutation circuit, and for this commutation circuit the circuit will be bulky and very costly. So to avoid these problems, we have to replace this circuit with this, not complicated one. It's so simpler than that, but things are somehow complicated. Let's see. This is a 12012 in transformer whose output will be a 220 volt AC according to Indian standard, and the input will be 12012 for the battery voltage of 12 volt. And here we will take two switches, S1, S2. We can make these switches as channel, combining one or more MOSFETs in the switching case, and positive of the battery will be directly connected to the zero terminal of the transformer. In this case we can achieve our goal. A problem of adding a commutation circuit will be resolved. You might think how this will be resolved. Well, in the transformer from 12 to 0 coil is wound, and from 0 to 12 another coil is wound. When battery supply, positive supply is given to the zero terminal, here we will see battery positive and here we will see battery positive. But as the two switches are open, this field will not store energy. This inductor will not store energy. But when S1 is on, in this case, this will start storing energy. By the energy of it, the output coil will be excited, and here in the output coil we will get some potential. As you know, once MOSFET is on, then MOSFET does not come to the previous position until and unless the terminals are reversed. And in the other case, S2 is off and S2 is on. In this case, this will store some energy. This coil will store some energy, and it will provide this energy to the output. In the same time, this will link to the first coil, and in this time, due to this magnetic field, this will face a reverse polarity, means B minus, and in this case the MOSFET will be directly off. In this case the MOSFET will directly off and will not on till the gate pulse is applied. And by applying this method we can achieve this. We can decrease our cost, we can decrease the shape of the inverter, and we can get a better isolation from the input side to the output side. fault can be occurred in the output side or input side. We don't want to damage any other system than the faulty section by the faulty section. Therefore, this transformer will give a better insulation against this. Let's demonstrate this. I am using P55NF60 in the place of S1 and S2. This one will be S1 and this one will be S2. I am placing these two in two different areas. I need to connect this source and this source directly because I'll supply this terminal as a negative. I'll supply this a negative voltage. So I put this in negative. I need to provide a gate pulse to the S1 and S2. These two are gate pulse will be provided by my audrino, and I will use this 12 volt 400 milliampere power supply. These two terminals. Use this 1 ampere transformer. The zero terminal will be connected to the positive supply of the battery. So I connected this, and the negative are connected to this. Here are two 12 and 12 terminals. This will be directly connected to the drain as I previously discussed. And here something is missing. That's a gate pulse. I have already programmed these to provide a 100 Hz frequency from A0 and A1. Use this HTC multimeter to check the output voltage. I need to set this at 200 volt AC, and here I will supply positive, and I am getting 63, 65, 64 or 65 volt output. I will get more power if I provide more power to the as battery, because I don't carry an battery, so I cannot power up this by battery. Very small power supplies, just the basic principle of it.